This should be the fourth rule or the fifth rule we are considering in this episode. This rule is a rule that is styled root power. When the number that you are expressing that is expressed in index form, a number in index form, has a power. It is not a positive power we are talking about now. It's not a negative power, but it has a power that appears like roots. If you are familiar with your numbers very well, you should know that when we are talking of roots, we are talking of a number that is expressed as a fraction of the whole numbers. What I mean is that when you have 1 over 2, that is called square root. When you have power 1 over 3, that is called cube root. Roots are always with 1 at the top. The numerator is always 1. Then the number below can be 2, 3, and 4. These are numbers that are called roots. Let me bring that to reality. When you have numbers like 2, or let me say 4, raised to power 1 over 2. Or you have 8 raised to power 1 over 3. This power that we have here, which is 1 over 2, power 1 over 2, this one is a root. And this root is called square root. Square root. We call it square root. Square root. Why do we call it square root? We call it square root because we are looking for a digit that we have to multiply 2 times, square. That we have to multiply 2 times, that will give you 4. I'm going to repeat that again. The meaning of square root is you are looking for a number that you have to multiply twice, that will give you 4. That's the meaning of square root. So you can say 4, if you know your multiplication table very well, it is 2 in 2 places. That means this is 2 raised to the power what? 2. So what is that digit that when you multiply it 2 times, it will give you 4? Then the answer is 2. That is square root. This is an explanation way, a way to deal with this using an explanation method. I call it explanation method. But that is not a way to deal with it mathematically. Mathematically speaking, when you have 4, the square root of 4, I've explained what I'm to do. It means that I can express this in index form. This is 2 in 2 places. 4 is 2 in 2 places. Then this square root is the same thing as what? Power 1 over 2. Okay? Then according to the power rule that we use, this is 2 into bracket 2 times 1 over 2. The power rule says that anything that happens to the power, just apply it. This is like 2 over 1 times this. Then you cancel this out, then my answer is 2. So the reason why they got 2 here is this. That is what we call the root power. It means that when you also have power 1 over 3, we mean to say that this one is called cube root. If it is starting from 3, you have to put 3 there. 4, you have to put 4 there. This is cube root of 8, which means that a number that you multiply 3 times, that will give you 8. And that is 2 in 3 places. So my answer is 2. But mathematically speaking, for you to solve this, you have to express this in index form. This is 2 in 3 places. Then this cube root is 1 over 3. Then it implies that use the power rule that we taught ourselves earlier on. This is going to be 3 times 1 over 3. Then this cancels itself. My answer is still 2. So in that case, when you're dealing with roots, is a way of looking for a digit that will be used to get the particular number. Is that you have it multiplied 2 times, or you have it multiplied 3 times, and so on. So we have, if it is power 1 over 2, we call it square root. This is the symbol. This one is called square root. If it is power 1 over 3, we call it cube root. Then this is the symbol. This one is called cube root. If it is power 1 over we call it fourth root. This is the symbol. Fourth root. If it is power 1 over 5, we call it fifth root, and so on and so forth. So if it is power 1 over n, mathematically we call it nth root. Nth root. Simply put, the number of times a particular digit that you have to multiply nth time to give you that number. That is what cube root is talking about. So I think you get the concept, then we'll move on from there.